Welcome next video on inferential statistics. Today we will learn about the estimation of parameter. This is the first statistical inference and second one is testing of hypothesis. So in this chapter or topic, we have to go for the student t distribution, which is the, about one of the most important distribution after normal distribution. And this is invented by William Sidney Gosset in 1908. He was an employee of Jonas Fairley in Dublin, and there are some restriction on publication. Means they have to share the amount they are getting. So on that case, he take a pen name students to publish the distribution. Distribution name is T distribution. And when this distribution will be used, this distribution will be used on the case of finding mean or estimating mean when sigma means population HD is not available. So that is the thing we need to follow. One more thing we need to know about the degree of freedom in student distribution, that is n minus 1. So this is the first time we are introducing degrees of freedom. Degrees of freedom is the number of variables you are free to choose from an equation. As for example, if it is x plus y plus z equals to 1, then number of variables is 3, number of equation is 1. So 3 minus 1 equals to 2 is the number of variables which you can take freely, and the third one you have to take from the equation. So this is the basic concept of degrees of freedom. Go to next. Next one. For student distribution, the simplification. Look, probability of mod t greater equals to t 0.05. Here t 0.05 is the probability, and the value of the t value is t 0.05. This is the point for which the t value within the bound is minus t point t 0.05 to plus t 0.05 is equals to 0.95. This 95, 0.95 in terms of probability, and 95 is in terms of percentage is the confidence limit or confidence interval. Now, what we need to understand here, two, three basic things. Estimator means we want to estimate a thing from the statistical data. So, what do we want to estimate here? So, we have to estimate the population mean or population standard deviation, population correlation coefficient. These things we want to estimate, and from which? From a sample data. So, estimator is the statistician who is doing this one. Estimate is the process, and estimation is the process. Estimate is the value of the estimator. Now there are two types of estimation. One is called point estimation, means a single point you will get as a estimation. As for example, if I tell you that what is the expenses for your next birthday for inviting 10 friends in a dinner, so you can say that 10,000 rupees. So 10,000 rupees exactly you are saying, then this is point estimation. And now it is not possible to be exactly 10,000 rupees. The percentage of being correct is very less. So in that case, point estimation does not have any meaning in estimation. Basically, we will go for interval estimation. So without saying for the same example, 10,000, you can say 9,000 to 11,000. Then there will be a chances of being correct. Now, there are some basic characteristics we have to follow for the estimator. One of them is unbiased estimator. Unbiased estimator is called, if theta is the population characteristic and t is the statistical characteristic, then estimation E of t, an expectation of t equals to theta, then it is unbiased, otherwise it is unbiased, biased estimator. Now there are some theory on estimation, but those are basically saying one thing, that when you are using the sampling process, as SRS WOR means simple random sampling with rate without replacement, and simple random sampling with replacement. These are the two cases. Another two cases are whether the population is finite or infinite. So you know that sigma by root n is basically we are using for all cases except the population is finite and the sampling procedure is SRS W1, means simply random sampling without replacement. Now, consistency is another thing. Consistency means it will go for simple process. You know what it means is consistent. But in terms of statistics, it is limited tends to infinity. Probability of Tn minus theta is greater than epsilon equals to 0. When Tn is the value of the statistics and theta is the population value. So let the population value theta is equals to 100. So all statistics value will be very close to T. That is the 0, or if it is reverse, or if it is less than epsilon, then it is equals to 1. Now there are some method of estimation. One of them is maximum it is used maximum likelihood estimate. This is the process how to estimate a thing. So in that case, you have to take n number of statistics in group of statistics. So in that case, you find n number of mean, n number of standard deviation, those things, and this is have to fit with some of the distribution, and then you can find by the maximum likelihood estimate by using the simple calculus of maximization. Now there are some maximum likelihood estimate values for mu and sigma. Mu and sigma, some values are given here. You can check them, but we will basically concentrate the confidence interval. Basically, you have to find the confidence interval for the population mean or the population variance. This is the two questions we will ask to you in exam. So let me go for confidence interval for the parameter of normal distribution. Margin of error, approximate confidence interval for the mean of any population. Let's come to this point, that approximate confidence interval for the mean for any population. Look, two cases can be exist. One is if it is the infinite population and the sampling is SRSW1, then you know that this is S by root formula, and if it is the SRSW1, then it is S by also same formula we are using. Approximate confidence interval for the variance of any population. This is the case. As you know that chi-square equals to n square by sigma square. Remember this formula, chi-square equals to n square by sigma square. The same formula will be used for any chi-square distribution in statistics. Now, some problem we are going to discuss. First problem, if expectation of T1 equals to 2a plus 3b and expectation of T2 equals to a plus b, then find the unbiased estimator of a and b. Look, two equations you have, just solve these equations in terms of a and b, nothing else. When you solve them, then you have to make some adjustment. 2a plus 2b equals to 2 of e of T2. Then you will get b equals to expectation of T1 minus 2 T2. So T1 minus 2 T2 is an unbiased estimator of as much as simple. And if you find the value of A equals to expectation of 3 T2 minus T1. So 3 T2 minus T1 is the unbiased estimator. So simple thing here. Now we'll go for some confidence interval for population mean problem. Look at the problem. 10 individuals are chosen at random from a normal population. So what you would write, the sample size n equals to 10. The height in inches is found to be, these are the values. Height is inches. So from this information, what will you find? You will find the sample mean and sample variance. On the basis of the above data, find 95% confidence interval for population mean when sigma is unknown. So it is written sigma is unknown. So you will use t distribution. So what are the conclusion? One is sample size n equals to 10. You will find the x bar means the sample mean, and you will find the sample estimate as x. Look, sample size n, sample mean equals to 68, sample variance equals to 9.4. So these values you need to find. Next, capital S, which is the population standard deviation. If you are using this formula, then you will get S equals to n by n minus 1 into S. This is the unbiased estimator we used previously. So this value is equal to to 6. Now t equals to x bar minus b. Look, t or z, whatever you are writing, the numerator is z, x bar minus 1. The denominator will be changed. Previously it is sigma by root n, now it is s by root over n minus 1 if you are using capital S. So this is the value, and obviously degree of freedom n minus 1 equals to 9. Now this probability of t greater than 2.262, this is given you know previous slide, is equals to 0.025 for 9 So greater than 0.025 for 9 So if you are taking from 0 to 2.62, then half of the distribution is 0.5. The distribution is also symmetrical about y-axis. So 0.5 minus 0.025, 0.475. Now double it from minus to plus, minus 2.262 to 2.262 equals to 0.9. So this is the probability you have to write in the right side for finding 95% confidence interval. So in terms of probability 2.95. Now put the value of t value, which is 68 minus mu divided by 1.02. Keep the mu and in the middle and the rest of the portion just make it both sides, and you will get that the sign distinguished to be minus 65.693, and this is the value for probability of mu. So this is a 95% confidence interval for population. Now another problem is discussed here. It is for 17 students, and its mean and variance are given. 99% confidence interval you need to find. So procedure is same. Just find the sample mean n equals to 17, sample mean x bar equals to 57, sample variance x bar equals to 64. So find the S formula for n by n minus mu into s, 8.24. Put the t value, x bar minus mu by sigma s by root 10. This is the value. It is given t greater than 3.250 equals to 0.05, and here the degrees of freedom equals to 17 minus 1 equals to 16. 17 is equals to the sample size x. So from 0 to 3.250, it is 0.5 in right side minus this portion 0.05, 0.49, and in next you will get double 0.9, 0.495 into 2. Put the mu 57 minus mu by this value in the middle, keep the mu value in the middle, and rest of the thing in left and right side you are getting 0.19 as the probability in right side, so that is 99% confidence. So this is the same problem we discussed, and if it is sigma is known for population, then it will be z equals to x bar minus mu by sigma bar. And last one, this is the problem for population is D. For 12 ball bearing were taken at random from a large stock, and their weight were recorded in grams. That's a Paris. When 98% and 95% confidence interval for the SD of the population of weight, assuming the population to be normal. Look, 1, 2, 3, 4 values are given, all are for 11 degrees of freedom. It is 12 ball bearing, so 12 minus 1 equals to 10. Sample mean, now you have to add all of them, divided by 10, 12, this 3.86. Sample variance formula is given here, you can easily calculate, and this is giving you 0.0369. Now chi square equals to n square by sigma square. N value is 12, x square equals to this value. Put this value here. Now we will come to the given value. Chi square greater than 3.06 equals to 0.95, and greater than 24.7 equals to 0.91. So if we subtract them from 3.06 to 24.73, it is 0.98. That is the 98% confidence interval. Put the n square by sigma square in the middle, and keep the sigma square in the middle, and distribute left and right side, so you are getting sigma in middle and both sides. So 0.98. So this is the 98% confidence interval for population SD, which is 0.133 to 0.38. And similarly, you can find the 95% confidence level of these data, 0.975 and 21 point, sorry, 0.025. So subtracting, you will get 0.95, and same thing, n square by sigma square. Keep the sigma square in the middle and distribute it left and right side. So you will get 95% confidence interval. Now, one thing to understand: lower limit is 0.449 for 95%, and lower limit for 98% is 0.16, and second one is 1.07 is the upper limit for 95%, and upper limit is here 0.38. 0.38, so very high. Look, when you are very close for a distribution, then your probability will be decreased. This is the example. Probability will be decreased. But when you are taking a less probability, then you will be very close to that. So this is the conclusion in distribution of parameter. In next class, we will go for testing of hypothesis. Thank you.